Good afternoon, everyone. Welcome to another webinar from Data Platform Geeks, and we are closing in on the second week of this series in March. And it has been a wonderful ride hosting one webinar each day in the month of March. My name is Amit Bansal, and I will be your host just for a few minutes, and then Hamish will take over with his session. A very warm welcome to Hamish. Hamish was a speaker with us last year at Data Platform Summit 2017. It's great to have him back on the webinar. Thanks to Satya, who is going to help us with moderation, with Q&A, and the overall execution of today's webinar. I guess many of you already know about eDominer systems and a couple of our initiatives that you can see on the screen. Under SQL Maestros, we do a lot of stuff related to Microsoft Data Platform, consulting and training primarily, masterclasses, accelerators. I want to let all of you know that we are announcing accelerators shortly. There is a link right now being given to the community where you can take a survey as to what kind of topics do you want in the full day classes of accelerators. We also have a self-paced unique learning platform called Hands-on Labs. Feel free to go ahead and create your account with Hands-on Labs, and you can practice many labs online. And of course, our favorite Data Platform Geeks, this webinar is hosted by DPG, which is our community initiative. And as many of you know, our annual feature, which is Data Platform Summit, which we organize each year. As of this year, this is 2018, which has already been announced. 3 days of conference on 9, 10, and 11, and 2 days of pre-con, 7 and 8. We get huge participation in this conference, primarily because we have world's best trainers, speakers, consultants, and industry stalwarts that fly down to Bangalore and deliver sessions. Most noted are Microsoft product team members who will come down from Redmond, SQL Cat teams, Tiger teams, senior product team members, and very heavily supported by our global MVPs and MCMs and industry solvers. We are very grateful to our speakers who voluntarily give their time to this summit and deliver sessions for the Indian community. If you wish to know more, just visit dps10.com. That is the website, and we call it dps10.com because SQL Server Geeks, formerly the predecessor to DPG, was formed in the year 2010. You have the phone numbers out there and the email ID in case you wish to reach out to any of our team members. DPG core team, I guess many of you already know. These are the people who work behind all these free events that we are organizing, and very strongly backed by our eDominer teams in Calcutta and Bangalore. Special thanks to Microsoft. They have been very supportive of our community initiatives. All of you are already members of dataplatformgeeks.com, and continue with your membership. Leverage all the free stuff that we have out there. You may want to know that all the past event resources, webinar recordings are posted on dataplatformgeeks.com. You can access event resources for events as old as 2010 and 11. So there's some really good stuff out there. Do join these groups. Facebook group and the LinkedIn group. Satya will put down the links to these groups very shortly. We appreciate if you want to put down questions and answer questions of the community on these groups. With this, and without any further delay, over to Hamish to take it forward. Thank you, Hamish.
Thank you very much. Alrighty, welcome everyone to this session on DevOps and the Data Professional. I am Hamish Watson. I'm actually speaking to you from Christchurch, New Zealand. It's about 10:30 p.m. at night. And in fact, my body clock actually thinks it's about 2:30 in the morning because I've just got back from the United States. I've been working in IT for a little over 7,000 days. I've been managing SQL Server for a fair while. And I've been working with SQL Masters Consulting. They're based in Brisbane, Australia, since January this year. You'll see from my bio here that I like to speak. The reason I like to speak is because I'm passionate about helping the community learn, and especially learning from my mistakes and hopefully helping them learn a bit more. I blog. My blog link is just there, and in fact the most important parts of this slide are my Twitter handle, blog URL and my community email address there. So in this session, I'm going to introduce DevOps. I'm going to discuss DevOps tools. More importantly, discussion around database tools. And I'm going to bring DevOps to a database via a live demonstration. So firstly, what is DevOps? Well, in the past, developers have been working away at getting new features and deploying those features out to the masses, whereas operations type people like DBAs have been looking after databases and applications, and they are driven by stability. And so there's been this power struggle between developers and operations, where developers try to find new and innovative ways to get their code out into production, whereas operations or DBAs just say no. And in fact, what happens is that the term DevOps, there is a definition on Wikipedia, but it doesn't actually encompass everything that DevOps is about. And so a lot of people are confused about it. And what also happens is that within our industry, there are so many buzzwords. And one week it'll be gamification, the next week it'll be cloud, and this week it's DevOps. And so what I did was, when I first started looking at applying DevOps principles to databases, I came up with a couple of things that I thought would help define it for both myself and also the people that I worked with. And it's around the ability to safely and quickly get changes into production. And we need these changes to be deployed in a sustainable way. I.e., we don't want a team of 30 people just to get our changes out safely and quickly. That's not sustainable. We also want our deployments to be boring, especially when they hit prod, because when they hit prod, we don't want any surprises. And we want our deployments to be able to be performed on demand. And what I mean by that is that all code, both application code and database code, stored procedures, functions, what have you, need to be should be in a deployable state, so that at the click of a button, we can push out all our changes to our systems. This here is how I sum up DevOps. It's around using our tools, creating a process that allows us to automate the reliable deployment of business value to our clients. Notice I don't say software, because I want to bring value to my clients. By bringing value to my clients, that means that I'm helping their experience. I'm providing a better quality platform for them. And by doing that, it means that they'll hopefully pay us more and be loyal. One of the things I use on Twitter to describe anything around DevOps is around making stuff go. And to me, that's the simplest definition of what DevOps is. It's about bringing things to the clients and making things go. My definition around DevOps is about all the continuous things. And during this session, I'll talk about what continuous integration is, how continuous testing will help us, and why continuous delivery is the deployment pipeline we want to use to bring that value to our clients. The reason why the first three are bolded is because for anyone looking at bringing DevOps to a data platform, these are the first three areas you want to look at. And once you've done those three, we then want to bring in continuous monitoring, because by having continuous monitoring right throughout our deployment pipeline, it means that we can scrutinize the performance of both our database and applications as we go along. We also want to fold in security right from the get-go. We want to bake security into both our database and the applications that are interacting with that database. Underpinning this is collaboration and communication between all teams, and in fact all people involved with our database, our applications, and the whole environment. I'm going to describe the database development life cycle. Generally, in the past, it has been manual. You know, people will be doing deployments manually, and they'll be doing testing manually. And in fact, the testing will be inconsistent because people are worried that during the testing process that they're actually going to break the database. And so by doing things manually, we're actually introducing more error-prone processes into our deployment. The other side of this is that generally databases are not in source control, or people are not using source control enough. And this typically I see this at client sites where stored procedures changes are just files located on a server somewhere. There's no versioning and it's not linked with application code. This all combines to lengthy processes and daunting deployments. And the reason that happens is because we're doing things manually, we're doing them inconsistently, things break, so we slow the process down, we try and introduce our own checks, where in fact we're just making the situation worse. And of course, application breaks our database. How many times has an application been deployed to and then something unexpected happens in our poor database? So I want to talk about continuous delivery and, more importantly, the principles. I want people to start looking at building quality in. If we can do unit testing before we even commit our code to our development environments, it means that we can find the errors early. And if we can find those errors earlier, it means that we can fix them quicker before they actually affect anyone. Fixing something on my laptop has far less impact on my clients than if that same bug or error is in production. And working in small batches. As we automate things, this allows us to cut down the amount of code that we're pushing out at any time. So we will work iteratively. And this is applying some of the agile principles that application developers have been using for decades. And again, by working in small batches, we can test the code as it's released. And it also means that we don't have massive amounts of code to try and remediate or fix if something goes wrong. We also want to automate things. People are not very good at doing repetitive, mind-numbingly tasks. We are far better at solving problems, at diagnosing things after they've gone wrong. And so by using automation, it means that we're not doing those mundane manual deployments at 3 in the morning. We can go on and look at higher value activities. So instead of being up at 3 in the morning and then I'm not at work the next day because I'm sleeping or what have you, I can actually be at work and not have to worry about the manual deploys or anything that went wrong because we've tested the quality, we've worked in those small batches, and we've automated the deploys. And we want to relentlessly pursue continuous improvement. As we automate things, we then want to automate more. As we test things, we want to test more things in our system. And we also want to keep automating and testing the whole way through. The reason for this is because as we improve our systems, it means that we can do more. And so by doing more, we actually want to test and automate more. And everyone is responsible. One of the key things about DevOps is that we all have that common goal of delivering business value to our clients. It's not about the best code or most elegant code that a developer writes, or DBAs saying, well, that's not my job, or stopping a deploy because they want to look at stored procedures. We want to be doing that together. We want developers writing more unit tests. We want DBAs to also be writing unit tests and working together so that as we deploy things out, the quality of our system goes up. There's no point in doing anything unless there are benefits. And some of the benefits of DevOps are enhanced customer experience. Because if we can have far better quality code going out to our production system, that means that our clients are happier. By working in small iterative batches and knowing that as they go through our deployment pipeline that they are going to be automatically tested, it means that we can react and adapt to client feedback. So that means that we can react faster and deploy better quality value to the end system. And by automating some of the deployments, by automating the testing, it means that instead of having people up in the night doing manual deploys, those same people can now learn higher value activities, i.e. they can learn how to tune databases better because they're going to have more proactive time as opposed to reactive time. Part of this, I see in industry, a company that I used to work for, we had a team of 4 testers who were doing all the manual testing. As we did more automated testing, we only had a department of 2 testers. We didn't fire or get rid of those other 2 people. They actually became developers. They could upskill. And that meant that we could actually start investigating things like test-driven development and those type of activities. So it allows us to be more proactive rather than reactive. And the upshot of this is that we now have faster time to value. We can actually bring our value to the client far quicker than what our competition are doing, because the competition is still doing things manually. The quality's not there. And so the clients will leave. So we want to beat our competitors. Here's an introduction to continuous integration, because this is the key thing about our DevOps journey. So what we have is a developer who writes some code, they'll commit it up to source control. We then have another developer who also writes some code and commits it up to source control. And then what we do is we take it into our continuous integration or build server and do some tests. And as you can see here, we've had a test failure. So the developer gets immediate notification. And what they can then do is fix their code right there and then, deploy it back up. It passes those tests, we commit it, and then we can go on to build and deploy. Continuous integration is a development practice that requires developers to integrate code into a shared repository several times a day. That check-in is verified by automated build, allowing teams to detect those problems early, as you saw in the animation I just had. And by integrating regularly, we can detect errors quickly and locate them more easily. And I took this quote from ThoughtWorks because I really liked the way that they described continuous integration. What you see here is not continuous integration. This is looking at different branches within source control. And we see one branch is 6,960 commits behind and worryingly 32 commits ahead. This is not continuous integration. This is a continuous mess. So I want to bold the bits that are really important to what continuous integration is. We're integrating our code several times a day. They're being verified by an automated build, and we detect problems early. We want to detect the errors quickly. But continuous integration isn't the whole story for reliable deployments. And what we see here is our developers doing unit testing. We're doing build testing. We then have user acceptance testing. But then what we do is we bank up 3 months worth of changes. So we've deployed to UAT a number of times, but then we deploy to prod, we roll it all up, and of course, things go wrong. And so what we now have is feedback on 3 months worth of changes. And we haven't actually achieved what we wanted, that reliable, boring deploy into production. And we have wasteful rework and manual intervention, and people have to look at what happened 3 months ago in the code. And so this isn't reliable deployment at all. We're still not there. So I want to introduce the concept of shift left, where we embrace all the continuances. And this is a better way, where we're doing a unit test, we're committing up to our build server via source control, and we do an immediate deploy to our little build system. And the good thing here is that we're getting immediate feedback. So this is part of the continuous integration process. And then what we do is we deploy out to what I call prod-like systems. And so these systems here, integration, functional, and UAT, are prod-like. They are the same structure and schema as production, but they may not be the same size. And in fact, the little cloud symbols there mean that some of them may reside up on cloud services such as Azure or AWS. Prod-like means that we have taken the model of production. Production might be a 1 terabyte database, but these databases might only be 50 megabytes, but we may seed them from source control or other means with test data and running our tests the whole way along. The main thing here is that we are getting immediate feedback the whole way through. So if something goes wrong in functional test, we stop. We remediate it back at the developer. We do the unit test, build test, go through CI build, integration, and if it passes, then and only then we will deploy to UAT. And if it passes everything in user acceptance test, we then will push to our pre-prod system, finally up to prod. And again, we're doing continuous monitoring the whole way through. And this means that the shift left part of this is that we are getting operational feedback towards the left as early as possible in the deployment process, so that we know how the application database will behave, both from a deployment perspective, but more importantly, from an environmental performance perspective. This is continuous delivery pictorially. I like this picture because it shows that we are deploying to CI and integration continuously, and then as we go towards the right, we're staggering out those deploys as we move up into production. And in fact, between the CI and integration environments, there's about 2 more environments in between there. It didn't fit on the screen. But yeah, as I say, we will deploy many, many times a day as we are committing that code up. If it passes those tests, it then goes up into, say, integration, system integration, and onwards. There are 4 pillars of DevOps. One of those pillars is around tools. We need tools. We are technical people, and without tools, we can't really do much. But what we found was, even though we had the right tools, our process was manual and disjointed. We were still having to do things manually, and things were still breaking. And part of how we solved that was around people. We needed the right-minded people who got the concept of continuous integration, continuous delivery. And what underpins this is culture, because culture will always trump process. And by bringing these 4 things together, you can achieve DevOps, because if you only focus on the tools, you'll fail. If you only focus on the process, you'll fail. Because I have a saying where the tools are great, but the process fails because the people don't get the culture. The thing is, there is quite a number of tools out there. And as you can see here, from a periodic table that XBA Labs put out, the choice is almost limitless. And so what I encourage people to do is to try things out for themselves, because the tools that are right for me will not be right for you. So get a little sandpit environment, a tiny one, and try these things out. And if it works, then start to grow. You need to start small. The reason being is you want to achieve some wins. You want to get a few runs on the board before you actually start to scale it out. So, some DevOps tools. We need to be able to track our workflow, how things are going, how to assign work to people. And so we might use Team Foundation Server. And we need source control. This is paramount. And so again, we might use Team Foundation Server. And we need something to develop in. So Visual Studio is flavor of the choice, as well as having an automated build, automated test server, and an automated release server. And generally, I like to put this up because I'm normally speaking at a conference where Microsoft are a sponsor. But this is the real world. And as I said, your tools may differ. And to be honest, I don't really care too much about the tools. You can do DevOps with Notepad. But I care about the process. And by working together, collaborating together, that's how DevOps will work for you in your database. One of the key things for me was infrastructure as code, the ability to spin up resources via scripts. Those scripts will be in source control. Those scripts will be tested. Those scripts will be automated, and those tests will be reusable. And this is where we had major wins by being able to spin up both database and applications by code that is in source control. Too often, I'd have to wait days for an infrastructure person to provide me with infrastructure that was wrong. Whereas by using infrastructure as code, and in this example, I'm using Azure PowerShell and I'm spinning up a VM, I know that it will work because I can test it and I can reuse it. And there are templates out there that other people have written for me to use. Just as important is being able to manage the configuration of our servers and all our resources. And PowerShell is very powerful at doing this. And in fact, there's a module called desired state configuration, which allows us to detect drift. So I may have created my server or database, and then as time goes on, we may have to install more new software. And so desired state configuration allows us to declaratively detect that drift and then use scripts to configure and install the software that we need. We also need a repository of configurations. This is fundamental, where we can set up variables, we can set up everything required to manage the configuration of our resources. This here is an example. We're using Chef and desired state configuration, and we are creating a new user, this backup manager. And so again, we're not using humans to do this because unfortunately, we humans are inconsistent. And there's some really good products out there that will help. Chef, Ansible, Vagrant, Puppet, Octopus Deploy, and some Microsoft products. At this point, I really stress to people to look at DBA Tools. DBA Tools is an open source framework that's developed by leaders in our community to help you manage your databases. And this website, https://dbatools.io, is where you can go, download the PowerShell modules, and they will make your life easier. I've seen examples where some DBAs have got, really huge T-SQL scripts that they've written and have to maintain, of course, whereas I can do the same thing with one line of PowerShell provided from DBA Tools. The best part, it's free. Here's some tools and techniques to bring about database change. Object relational mapping is one method of how we can take our application and interact with our database. This is around the code first approach. Microsoft also have SQL Server Data Tools, or SSDT, which has a DAC pack, which is a model of our database that we can deploy out and publish those changes to our database. And of course, PowerShell, infrastructure as code, being able to spin up databases, to configure databases, to detect that drift. And source control is paramount. By having source control, it means that we can have a known state of our database. we know who made changes, we know what changes were made, and we can deploy out our database changes and our application changes from the same source of truth. And standards are mandatory. This means that at any one time, we know exactly where our databases are, what users will interact with them, where the particular config files are, etc. So object relational mapping, it has its uses. This is the code first approach to defining our database. It's a migration-based deployment strategy. It speeds up development, but only in certain cases. It makes data access more abstract and portable so that application developers don't have to worry too much about the underlying database, and therein lies kind of the problem. And allows business rules to be in the data access layer as opposed to storing that in the database's stored proxy. And it generates boilerplate code for basic create, read, update, delete operations. However, please be careful using them. This is tools like Dapper, Entity Framework. You can write very horrible code very easily with them. On the flip side, we have SQL Server Data Tools, which again is representing a model of our database, which is called Data Tier Application, and the output of that, the package, is a DAC pack. And it's used in conjunction with Visual Studio and allows us to develop our databases as code. This is really important because we can then commit those changes to source control and then push that DAC pad out to our dev databases, our build server, and then deploy to our on-premises databases and or Azure. And it's a state-based methodology of pushing changes to our database. And there's a couple of ways that we can do it. There's SQL package.exe, we can use PowerShell, we can even use Management Studio, as well as some APIs. Source control, it's kind of like breathing air. Without source control, you're breathing dirty air. It won't kill you, but you will get sick after a while. And so I always say that having source control is like breathing clean air. There's a couple of different versions of source control out there. There's two types, the distributed type and centralized. Most people these days are using Git. And here's the thing. Application developers have been really spoiled because unfortunately our tools don't play nice. But there are tools that can help us DBAs or data professionals out. Redgate have got a really good source control utility. There's also SourceTree by Atlassian. There's Visual Studio and Team Foundation Server, as well as the online version of that, Team Services, and Git commands themselves. And so here's an illustration of SourceTree, where we're looking at branches. We can push changes up. This is within Visual Studio, where we might be using Team Explorer to push up our changes. And this is Git commands themselves in PowerShell. So here I'm looking at some, I'm looking at the status of my branch. There's some changes that I need to push up, and so I can do that with Git. People think that by automating more that DBAs will be out of a job, where in fact it couldn't be further from the truth, and in fact it's the opposite. We need DBAs who understand automation. We need DBAs who understand source control, because the more we can automate of those mundane, problematic processes, it means those same DBAs can focus on more proactive things like tuning indexes, tuning queries. And so there's a couple of blog posts here that I really like that explain it so well. And as mentioned, we're always going to need to tune indexes in our databases. Most importantly, we need to test our databases, because companies would not hire a .NET developer who didn't test their code. In fact, they wouldn't hire them at all. Whereas when it comes to our databases, people say that it's too hard. because you know the underlying data. That's even more reason to do the testing. Our tests need to be repeatable, automated, and various kinds. So we want to do unit tests, logical tests, functional tests, QA tests. And we want immediate feedback from those tests. And then we can test for our mistakes so that we don't repeat them. So if we make a mistake, we write a unit test for it. And that way we know we'll never make that mistake again. Which leads us into test-driven development, because test-driven development is really important for understanding the end result of our code. This is where we write the test and then we write enough code to pass the test, and then we commit and push out. At this point, I'm going to do a demo showing bringing DevOps to the database. And so what I have here is a VM that I have in Azure. I have a SQL Server on my VM when it wakes up. If it wakes up. I had a wee bit of problem flipping between screens before we came online. And in fact, SQL Server Management Studio has not liked that at all, but that's okay. This sort of leads me into Visual Studio, which I have here. I am using SQL Server Data Tools here in Visual Studio. And most DBAs are hesitant about Visual Studio, whereas in fact we don't have to be, because SQL Server Data Tools was built in such a way to make our lives easier. So I'll just wake up SQL Server Management Studio. So what I'll do is show you the database that I'm going to interact with. This database here, Dev Farm Safety. And what we have is we've got a stored procedure in there, and we have a whole heap of tables. And what I need to do is we're going to create a new table in here. We're going to create a new stored proc here, and then we're going to deploy it out through our continuous integration processes and our continuous delivery processes. Because what I also have is up in Azure, a database that we deploy to immediately in our CI processes. This database here. CI, farm safety, and see where standards come into play. I know that this is the CI one. I know that this is the build for another system, and I know this is the UAT one for another system. But anyway, so up here, we also don't have the stored procs. So what we are going to do is develop them on our dev system. And what I've done is imported my database, the dev database, here into SSDT within Visual Studio. And I just have to find my script. Okay, so I'll just put this in Notepad. So I've got a copy up here. So what we're going to do is we're actually going to create a table, and we're going to use SQL Server Data Tools. And as you'll see, we're going to see a very familiar view. I'm not writing any C# code. All I'm doing is I'm using T-SQL to define my table. So this, for me as a DBA, feels very, very similar to what I'm used to. So I can now save that. Now what I'm also going to do is I'm going to create a stored proc. And to save on time, I already had the stored proc here. And so if I come up here, here's my stored procedures. I'm going to insert farmers into my database. But what I've also done is created, and it's as simple as a right click, unit tests for my stored proc. And so the unit tests within SSDT adhere to the standards for unit tests. So there is an assemble phase, an act phase, and then an assert phase. The assemble phase is where I set things up for my system. The act phase is where I'm actually calling my stored proc and feeding it in some variables. And then my assert phase is where I actually test whether or not that worked. And so what I can do now, so this is the unit test for the stored proc. So I've made changes. I'm going to save those changes. And then what I can do is I can immediately publish those using the DAC pack that SQL Server Data Tools will create for me. So it's done the build here in the background, and then I can immediately publish to my dev database. And so that's completed successfully. If I come in here, right click, refresh, I now have my stored procedure. And if I come into tables, I'm hoping that I have one called farmer. I do. This is good. Now, at this stage, I could easily come in here, and I can't because that's in the way. I could easily run my unit tests, but I'm not going to, and I'm not going to for a very good reason. I'm going to show you DevOps in action. And so what we have down here is we have our Team Explorer. This is connected to source control. So the changes that I've made, you'll notice that I have a new table and I have a stored proc. So what I'm now going to do is push this up to source control. And what will happen is we'll go and visit source control, and I'll show you what I've changed. And more importantly, we're going to see this in action. So this is pushing up to source control, it's committing to source control. And then if we go to my systems, so I'm using Visual Studio Team Services here. And what I have here is my project, the Farm Safety Project, and you'll see there that changed to in progress. And look, creating stored proc a new table for data platform demo. That's you guys. So let's have a quick look at what's happening. And what this is continuous integration. I'm committing to source control, and I'll quickly show you source control. So this is Git. I'm using Git for my source control. And there are branches, there's pushes, commits, but I'm going to just leave this here for a second, because one of the important things is we build our solution and then we run tests immediately, so that if anything fails for whatever reason, we'll get immediate notification. So what's happening here is in the background, Visual Studio Team Services is validating the model that SQL Server Data Tools created. It's then pushing that out to a database for us. And then it will, what it does here is it's creating a new database. And so that database is this one here, Build Farm Safety. And then, and then what it will do, see here, it's created all these objects from source control. And then what it will do is actually run our test on the database. This database here was built from source control. So we tear it down, spin it up each time that we want to do things. Oh, I keep going the wrong one. We've got a failure. What's our failure? You'll see here that we have a failure. And it's around this column priority. Ooh, that doesn't sound very good. Now don't worry, I did this on purpose. I failed this to show you what would happen. So what I should have done was run the tests here. And in fact, what I'll do is I'll run the unit test here. And what I have in this system, I have a number of tests. I have a couple of the unit tests for my stored procs, and I also have these. These are application tests. These are what the application developers have written, and I'm writing tests for my database. This is so powerful because this means that we can do integration tests. So I already know why this failed. It's because, you know, I'm not the world's best developer. I forgot one of the columns. But if I had run the unit test immediately, I would have known that, and I'll show you. Actually, no, I'll follow procedure. So once I've saved this in my model, it's picked up that there's a change. So the DLLs have been recreated, and what I'll do now is publish that to my dev database. So again, it does the build, and it will do the publish, which is all very quick. And apologies, the reason I have to keep doing this is I can't see the toolbar. Boom. Our unit test worked. So that means I can now deploy with confidence. I am confident this will build. Notice that we have not gone any further than just our build database. So we published the changes here. We built this, tested in this, it failed. I get immediate notification. I then make the change. And now again, I've pushed up to source control, which then will hopefully kick off another build. And again, this is all automatic. I can be doing other things while this is happening. I am confident this will build. Well, I hope it builds. It will build. So what will now happen again, it'll go through the same consistent build steps it did before. And so while we wait for that, what then happens is we then, after the build, we will then release to our databases. And Visual Studio Team Services has a really cool pictorial representation of our pipeline. So what it means is that once we've done our build here and it's succeeded and all our tests succeed, it then deploys to our CI environment, and then we go into our integration test environment. And so again, this is the collaborative part of DevOps, because we can have processes in here that application, so we can do .NET Core, we can do Android stuff, we can do anything we want within our deployment process working together. But this particular one, I'm interested in deploying just, you know, out to Azure SQL in this instance. And again, notice that these are all variabilized. So this comes back to that configuration management. So we have variables here that we have throughout our deployment pipeline that we can use. So if we come back to our build, oh, notice that the test succeeded. So now it's going to publish a standard package of our DAC pack, and it will now, hopefully I'll come in here and about here somewhere. So this release, if I click refresh, we've got something going. So this is now releasing to our CI environment. Notice again, it's automatic. It's an automatic trigger that on successful build, we will deploy to our CI environment. So it's now executing that DACPAC task. So it's publishing to CI farm safety on our Azure server. So what I can do is come in here. So we expect to see a stored procedure here and a new table farmer in here. So hopefully this won't take too long. Now, the only problem with my systems here is that because they are up in Azure, I don't spend much money. So they take a wee while to spin up. So in fact, this might not finish within the time frame. I'll give it another couple. Okay, so it's updating the database, which is good. I'll give it probably another 2 minutes. Cool. Hey, it did something. And it finished. The cool thing is, if we come back to summary, where are we? Apologies, come to the right place. Notice that it's moving on and it's deploying to our integration system. So it's doing that immediately. And so this integration test environment has been set up that if CI succeeds, we'll do that immediately. So let me show you the proof. First of all, we'll do our stored procedure. Hooray! And hopefully our table. Boom, farmer. This is a consistent, repeatable, reliable deployment of our changes. I've only focused on the database here because this session is called DevOps and the Data Professional. But we could be deploying application code at the same time. So I want to show you one thing that I think is massive in the world of databases and more importantly, DevOps. I'm going to connect if this allows me. Let's see. So integration test succeeded. I want to show you why I have an integration test environment. Because remember before we had the DACPAC stuff? Well, this is doing tests as part of integration testing. And if I connect to my integration test server, we have the two stored procs now. So that stored proc was created. You probably guessed by now that this is running on Linux. I've deployed to SQL Server on premises on a VM, to Azure SQL and SQL residing within a container on an Ubuntu VM, again on Azure. And again, that's the SQL Server Management Studio is not loving me tonight. But this is the key thing, that we can now have this deploy process here is repeatable, reliable, and now that I like the fact that this is going, I can then hit approve and send those changes through to my UAT system if I so desired. Just want to see. One of the great things for me about SQL Server on Linux is the fact that I can download images and run them in a container. And so this is running on Ubuntu on Linux, and I'm running the latest version of MSSQL Server.Linux. I could run CU3, CU2, CU1 of this version of Linux, which is SQL Server 2017, all via script. That's pretty powerful. Okay, so now, if I can find, these were the game changers for me for bringing DevOps to the data platform. Infrastructure as code and configuration management, being able to do things via scripts, via things that are in version control. Source control or version control, I I flip between the names. It doesn't really matter. Source control for all activities. If you are not putting your application code in source control, you need to immediately. And if you're not putting your database model in source control, as you saw me do today, you need to start looking at it. SQL Server Data Tools and Redgate and even Entity Framework, there are so many options to do this. You need to look at it. You need to test. I showed you how valuable testing is. And in fact, if you don't want to test in Visual Studio as I did, look at T-SQL T. T-SQL T is an open source, free framework that allows us to write unit tests within SQL Server Management Studio. It's really powerful for DBAs who don't like Visual Studio. We want reliable automated deploys on prod-like systems. The three systems that I deployed to tonight, or today rather, are prod-like. They were consistent at one point, and then as I roll through my changes, I bring them all in line. I want to fail quick on my CI or on my dev environment, and I want to celebrate lots in prod. I want my deploy in prod to be mundane and boring. And utilizing Azure or cloud for spinning up resources as required. All those databases I can tear down with one line of PowerShell, and I can spin them up again with one line of PowerShell as required. So it's not going to cost me a lot of money. The summary. The goal is an automated, repeatable, rapid, reliable delivery of value. We want to make our clients love what we do with our databases and apps. We don't do out-of-process changes ever. We do not go into prod and change a stored proc. We change it in source on our dev machine. We commit it to source control. We adhere to continuous integration and continuous delivery processes. Don't underestimate unit tests, and please look at test-driven development. I'm really passionate about the value that that can bring to our industry. And experienced DBAs and dev are integral to achieving the goal. We need DBAs more than ever, DBAs who understand testing, automation, and source control. Automation is cornerstone. The more we can automate, the better. Communication and collaboration and culture will dictate success. To get where I am today, I didn't get here via tools. I got here via collaborating with developers, collaborating with operational people, communicating with infrastructure people, bringing it all together to, again, hit our goal of just boring deploys to prod of both application and database code. For too long, we have had two different stories for deploying change to our systems. Database people did it one way, application people did it other way. We have to bring it together. We have to use the same methodologies because app people have been doing this for decades and been winning. We need to as well. If there are any questions, I'd be happy to answer them now. By the way, this person here is a guy that first taught me the value of DevOps. So I always have him on my question slide. He was a tester who became a developer and showed me how fantastic being able to use code to represent my database was. And so I'm very grateful for what he's done for me. Thank you so much for being part of this session. I hope that you've learned something. Here are my details. That is my community email address. That is my Twitter handle. And again, my blog. And I'll leave it over to Amit now. Thank you all very much for being on my session. Thank you.
Thank you. Thank you, Hamish. It was really kind of you to spend this time with the audience here in India, and I guess many of them might have joined from other countries too.
Oh, it was my pleasure.
Of course. How was your experience, Hamish, last year at the conference? Did you enjoy?
It was life-changing. I absolutely loved it. Both from the caliber of the speakers, the enthusiasm of the volunteers, and I have to say, it is one of the best conferences I've ever been to, and I really hope to be there this year. I was amazed. Perfect,
Hamish. We hope to welcome you once again this year. And For the audience, just want to quickly let them know that we have, just like last year, this time we have 12 pre-cons, full day classes as part of DPS 2018, 6 on the 7th of August and 6 classes on 8th of August. Just take you through a quick run through. Dimitri is going to do a full day pre-con on SQL, performance tuning. Sunil Agarwal from US, Principal Program Manager, is going to do a full day pre-con on SQL, Azure and Managed Instance. Reza Rad will be doing a full day pre-con on Power BI, and he is an MVP from New Zealand. We have Dr. Leila Itati, data scientist from New Zealand. She's going to do a full day pre-con on artificial intelligence and data science. She has 2 pre-cons, one on August 7th, the other one on August 8th. Andy Leonard, worldwide expert on SSIS. He's going to do a full day pre-con on SSIS and ADF. We have Madan Gajendran. He is one of the founding members of Cosmos DB team. He, along with his Microsoft Cosmos DB team, is doing a full day pre-con on Cosmos DB. When I say pre-con, I mean full day deep dive demo-based advanced classes. Leila Tati again on artificial intelligence. Then we have Steph Locke from UK. She is an MVP and worldwide expert on R and Python and whatnot. She's going to do a full day class on R. Sanjay Mishra, who leads the data CAT team as part of Azure CAT team, is going to do a full day pre-con on building a scalable data architecture with Azure. Joey and Denny are doing 2 separate pre-cons. Denny is doing a pre-con on high availability and disaster recovery, and Joey is doing a full day pre-con on Linux for the SQL Server DBA. And one of our popular speakers from last year, Peter Myers, is back, and he's going to do a full day pre-con on analysis services. He's an MVP from Australia. So we have 12 international speakers doing 12 different pre-cons. And you're most cordially invited to explore in case you wish to join the summit. Summit is 9, 10, and 11, and the pre-cons are on 7th and 8th of August. This conference is one of its kind. Here are the links and the coordinates for you to talk to our team in case your managers are interested. Reach out to your managers and company to explore more. Well, with this, we will close the session, and we have this Facebook group and LinkedIn group. I hope many of you have already joined there. We are going to put a group picture there in the Facebook group. Do like it and put some comments. Our speakers will be more than happy to see your feedback and make improvements as required. A quick word from one of our sponsors, SQL Maze Pros. Explore this hands-on lab solution, which is a unique learning platform. You can create your free account and access more than 100 different labs on Microsoft Data Platform Stack. We have more than 30 technologies that we are covering, starting from SQL Server DBA to Dev to Azure Data Factory to Azure SQL DB, machine learning, data warehouse, and whatnot. Power BI also. So there's a lot of stuff out there. With this, we thank you for joining us today. Remember, there is an artificial intelligence and data science event coming up this Saturday at Microsoft Bangalore. I am also going to be there along with 4 experts from Microsoft. It's a full day event on artificial intelligence and data science as the theme. Microsoft Dome Door office and Embassy Golf Link Business Park. And of course, it's a full day event, so we have lunch for all the attendees and speakers as well. Join us if you're keen on these topics. And webinars continue to happen. Next Saturday on 24th, we have events in Bombay, Delhi, and we're planning an event in Calcutta too. With this, we thank you for joining us today. And now we will start the Q&A. So please use the Q&A panel to ask questions to Hamish. We can definitely do Q&A for next 5 to 10 minutes, and Hamish will be more than happy to answer questions from you. And for others who are leaving, goodbye. Thank you for joining us today. You have a great day or whatever is remaining of it.